Okay, so light,
When I said, hey, Nick, look, there's new layouts.
light in the test, but not because I'm not going to use that.
Are those angles or sides?
They're points. They're vertexes. So, if you are asked the tangent of, if we're going to be accurate, x, z, y, let's name it with 3 points, we know that's the slope ratio made by that angle when relating opposite to adjacent. So it's xy over yz. Done.
And that's inside kind of the slope angle?
That's all you would need to do for that problem. If the problem said what is tangent of xzy, boom, done.
Oh, that makes sense.
Satya's brain is struggling because he's like, wait, is this easy?
It's too easy. Something's
So
wrong.
that's why we start you without the numbers, and then later in the test, here's some numbers, do it again.
Wait, so just be... Oh, but I'm confused. No!
Fair.
The thing that's in the tan, the thing that tan is multiplying, will it be a degree of an angle or a side length?
This is always plugging in, when using tangent, the angle. Now what you're getting screwed up on is if we allow ourselves to use the inverse tangent, but that's a result of needing
That's
to
only
use
defined
it.
theta.
This, we plug in the ratio of side lengths. So like this, if you know this, and you don't know your angle, you use inverse tangent and you're plugging in ratio. You are you're never plugging in a single side length. You're always working with either the angle that is made or the ratio made from the angle.
So if I were to, can I come up with a word?
No. But what you're about to ask about is probably this, right?
No.
So if you were asked tangent of x,
So I was asked tangent of. No, I'm asking like.
Are you asking?
I don't know what I'm asking.
So what do you think, dude?
okay, so I want to check your comprehension. If we ask you for tangent of angle x, which is 3-point notation, we should write it, it's 3 point. But if I ask you tangent of angle yxz,
It would be opposite over adjacent.
But
So
what
it
is
would
it?
be yz and then yx.
that's it. If I asked you to solve for x, and you didn't know it,
So it's just opposite over adjacent.
so if I asked you to solve for x, right? Hang on. You would need to just do that. The same resulting ratio is what gets plugged into the inverse if we're trying to go backwards and find the angle.
So this side was A, this side was B. I want to find out A.
You have to know the angle. One of them.
And I know this.
And if you know that, you also know this, actually.
Yeah, so if I know this, then I put in tan. Ignore that. What tan
Whatever your
theta.
Yeah.
I'll call this theta, and then I'll do A divided by B.
Equals.
I get it.
Good. We can move on.
I get it.
Hey, Satya, was that a light bulb moment?
Mr. Hudson,
It's like finding a song that you know only one lyric to.
Yeah, let's see who works.
you only know one.
I don't know. All right. So today we would like to dig into 412. Yes.
Mr. Hudson,
I have a joke that Levi wants me to share.
What is it?
It's a point.
What did the suicidal triangle use? The hypotenuse.
Oh.
God.
Another bad joke.
You just picked that up.
It's so bad.
Disappointing.
So bad you have to share.
Okay, the pun is good. The
What is
bad
the-
part.
I have a joke.
I mean, the context is a little
Mr.
depressing.
Hudson, what does a lawyer say to the other lawyer? We're both lawyers.
What?
Why can't dinosaurs
Okay.
laugh?
It's why can't T-Rex laugh?
No, because they're all dead.
It's why can't
you hear pterodactyl peeing?
It's
Because
why
they're
can't-
gonna think you're gonna say because it's
Yeah.
silent, but no, it's because they're all dead.
It's not why can't dinosaurs laugh. It's why can't you
Why
laugh?
can't you- What happened first?
No one likes your modifications. Get out of here. No one likes you.
You have to use the ones off Reddit.
I bet you're gonna go home and play some Fortnite. Get the
I think Mr. Hudson wants to leave.
I'll silence.
I'm not clapping for that.
Okay, less than 4.1 points.
Nice silence.
Okay.
What's even happening?
Not sure yet. Or something.
Did you just bring up Reddit?
Yeah.
Okay, no, I'm serious. This relates.
r/yes.
r/whoosh.
No, for real. So I'm currently in a conversation with somebody in the r/math education page, and I might ask you guys for help. I'm trying to help him. He's a high school teacher, trying to figure out really how to make like the middle school math content make sense to middle school students because he's too smart, right? Like he's struggling to teach basic concepts because he's too smart. So I might like copy out some of the thread and see if you guys would like write up some responses from an 8th grade standpoint. Here's what you can try with your kids.
So he's
Would
like-
you have any interest in that?
Yes.
Sure. Is he like, why do you want to say?
So he is trying to do subtraction of positives and negatives and like binomials. So take like binomial minus a binomial,
Yeah.
but take like 5x plus 3 minus 3x minus 2 or something like that. So taking away the negative value is yeah, but how do you get that to make sense?
Oh, you could just say, so you have a minus and
So,
then another
we'll
minus.
potentially dive into this later, like tomorrow or Monday, Tuesday. That might be the activity that we do while people are still in lab, whatever. But it's just funny that you brought up Reddit because like I've been debating whether to get help from you guys.
Mr.
on
Hudson,
this.
if
Yeah.
you take debt away from someone, you're giving them money.
Yeah, right. So like ideas like that are what I've been trying to share with him. But still, it's like it's adults trying to
It's
get
like a
kids.
number line. So like if it's -5 and you're adding like 9 or something.
Yeah. So these would be the different viewpoints that I would love to get.
This reminds me of, like, I play Magic and Santi plays
So do I.
Magic.
And I
Well,
can
I
beat
do.
you.
Yeah. Probably can. But like when you're
Anyway.
teaching new people to play the game, you just okay, so you tap this and they're like, what the heck is tapping?
I know, I'm like,
Yeah,
You
you
just
so
assume
you-
they know the basic
That's the
concept.
problem. So he's like a calculus teacher trying to teach middle school math and is struggling,
He
which
shouldn't
makes
be
sense.
teaching.
The problem is once you don't do something for a long time, you forget how to teach people at the low level, because you know what you know, and you know it.
It's like, why do you know this? Oh,
So it
you
was
know
like
it.
me trying to teach you trig. We had a disconnect because like I'm just good at trig. I like it. I love it really. It's one of the reasons that I honestly fell in love with math because it makes so much sense and it's so applicable.
Hold on, there's this picture that I want to find.
No, we got to dive in.
Okay.
So
Fine.
area models. Now I think this lesson should be faster, which is why I let us go off on that tangent for a minute. Area models and multiplication. Now this is where I hate what CPM did. For a long time, CPM had our generic rectangles operating with like 25 and 15 or things like that. Now it's left and bottom. So if we look at like the powers of things involved here, we know that an x has to be here and an x has to be here.
Yeah.
Now we could write it up here, but then we're splitting where the x's are. So now when we go to write out the area model, we're going to end up writing the dimensions or the factors on the left side and the bottom. So please go ahead and put this rectangle in your notes.
I can solve that.
So what we know is my x values have to make a 10x squared. Today is the 10th, yes.
Overachiever.
I mean, it's better than underachieving.
I could disagree.
Actually,
No,
it's a
I
I
can't.
mean, you could, but you'd just be wrong.
Whatever.
Yeah,
Sure.
same.
Done.
Oh, this is easy.
Yep.
Oh my god.
Copying the Josh.
I'm at
Eat
my
my
Negative
Ah.
7.
Oh, dude, fast.
X squared
There's no negative.
You have to do it precise,
Oh,
Jacob.
I
You cannot be messy.
7, negative
I said messy. I
It's
was
negative
messy.
7, 2x, 5x, negative 2.
7.
Hey, he dies at the end of the movie.
Who, me?
No, you guys are doing it again. Don't just yell out answers.
I wanted
No, but in this room, you're talking to everyone.
Mr. Hudson, we're 8th graders.
I don't know why my brain just did that, but that's a 14.
How would that work? I need to start drawing my fours like that.
So, as opposed to triangle, or what?
Yeah,
Yeah,
whenever I
yeah,
draw
you're
like
forcing
triangle.
Alright. So yesterday, we looked at a little bit of algebra tiles, and we're going to get them out again.
Yeah.
Potentially potentially all of us, but since they are like they kind of take a lot of time and stuff, we might just like try to orchestrate it together. So I heard some people saying, well, this is easy. This is so I got to put my x's here, right? Because I know I make the x squared, but then I need to figure out their coefficients, and I can kind of do that by negotiating the fact that this is going to be part of making the 35, and this is going to be, or sorry, this is going to be part of making the -4. Yeah, but I'm talking coefficients now, right? So we need something that multiplies that by this and makes -4x, and something that multiplies this by this and makes -35x.
2 and 5 is 5 and 2. What's the difference?
So what goes here? 5. And even if I'm guessing, chill. We're guessing. We're just trying it out. So if I put a 5 here, what would need to go up here? -7.
Lauren, it could work. You could do -5 and -2. But Lauren's wrong.
If -7's here, this needs to be -2. And if this is -2,
Dos.
Regular 2.
That would be regular.
Yeah, regular
That would be
2.
regular 2.
-7, 2, 5, -2.
That's right.
If we then write this out, we have 2x minus 7,
Whoever's kicking the stairs.
5x minus 2.
I swear to God, it's not.
Are you with me? Yes.
So far, yes.
I understand this is out.
Then, because I like to keep sprinkling in the stuff of where we're going,
Quadrant.
if we were asked for the zeros, or where this passes the x-axis, we figure out in each parenthesis what would make it 0, and the trick for that, opposite, and we make a fraction, right? Because I want this to become a +7, right? Because 7 minus 7 makes 0.
Oh.
So how do I make this become a +7?
3.5.
I multiply by the opposite of this value divided by the coefficient. So forget about the decimals. Fractions are easier. Opposite of this value divided by the coefficient.
2/5.
And that would tell us where we cross the x-axis. Then, as we keep analyzing, because we're not at we're not at parabolas yet, but we're getting there, we would analyze 10x squared, right? If I write out the quadratic, minus 39x
What equals?
plus 14, that's our y equals. What way,
Like level 1,
what way does this parabola point?
all of them.
Up.
Is it a standard like this, or has it been flipped and it is now like this?
If the x is 0, that means that it's
What do we look at?
The -39.
the values of x.
Not the values of x,
Coefficient?
because we don't know what x. We look at coefficients, but what coefficient would tell us if it's been flipped or not?
Square.
The x squared.
The
Yeah,
coefficient of x
squared,
squared.
yeah.
The x squared part.
Squared.
That would make sense.
I feel like we need to do this.
-39
Check this
part.
out.
It must.
I'm really torn.
Okay, why did I get tangents? Why did it take me 7 days?
I don't know.
Nidden, please stop, bud.
Okay.
If you would like to play with,
What? This one?
excuse me, anything, one really cool thing that Desmos does is it gives you sliders. So I don't know how much we've used Desmos, but as you know, it's the test for the state of Ohio.
Wait, we use this as a test?
Like the Desmos is the calculator function on the state tests.
I see.
So if we have a slider for all these values, right now I have 1x squared plus 1x plus 1, right? But if I move C, what happens?
This goes up and down.
So what is C determining?
The y intercept.
Yeah, that should be easy, right? C is determining the y-intercept. So I'm going to leave my y-intercept to like 3. Okay, A, B is the weirdest one, so we'll come back to it. A
Width? No. Yeah, it is width.
is your steepness, right? Or your intensity, some people say. So as we get closer, now wait a minute. If we have 0x squared,
It would T-pose.
What is so? What 0x squared is?
Try it.
It's a line, right?
Almost.
Because if there's no
What?
x squared, it's not parabolic.
It's T-posing.
Well, not if I make my slope 0, then it would T-pose.
T-posing.
So, but wait, so B changes our slope, but wait. If I put this back to a parabola.
It changes the direction.
Oh, it
No,
changes
what?
like.
So, sorry, I needed to show this. If it's negative, it means it's been flipped upside down. So, to answer our real question that I was asking, is this pointing up or down? It's pointing up.
Yeah,
It is
yeah.
concave up because this is
Okay.
positive. But, hold on, this is where your brain's going to, like, leave stuff on my
Flip
floor.
inside out and
It's
not
gonna,
work
like,
anymore.
rotate.
Oh, but the carpets
Oh,
are
you think we're
so
gonna-
So, watch what B does. As I make B positive,
What?
Oh, I
Scary.
understand.
It's a
Going
parabola.
Wait.
Parabola.
Oh, wait.
It's like on a parabola.
Wait.
Circle.
Jacob, how's it moving?
Oh,
In a parabola. In
It's
like
having
a
across the line.
So, notice I said Jacob and then 5 people talked? That's not how this is supposed to work. Jacob,
a parabolic way.
as B, if B's the only thing, right? So, Jacob's saying if B's the only thing changing, it's moving parabolically. What, like, so if I move this up, it's a little bit easier to see.
Yeah, see how like
It's taking a parabolic arc in its shift.
the line shifts.
Now, what is also really changing is what the x-intercepts are. Which, when the x-intercepts change, that pushes everything, and that is also what causes that to happen, because the intensity doesn't change. The y-intercept doesn't really change.
So could you get one that only had one y-intercept and no x-intercepts?
Steven, thank you for raising your hand.
Can't you have like 2 x-intercepts if it goes like
Yeah,
that?
we do right now.
Always
Yeah.
has to it.
Yeah.
Well, not always.
Now, you could also just have no x-intercepts,
Could you have one?
or one if you just touch the line.
Barely.
Now, this still might not be quite right. I'd have to like zoom in and fix it and like try out different wheel values. But I still actually crossed twice here. So, and you can adjust your slider if it gives you hundredths or what, but this gets really difficult.
Oh.
Yeah.
Keep zooming in.
What if you make the A 0 and then try the B?
Oh, then it just changes your slope because then it's no longer parabolic,
Yeah.
Oh.
It's-
okay.
just linear.
I thought
So this is different when it's just linear.
See like x-intercept is 3, B is just slope. Make it vertical.
airplane.
All right. So, and this is why I was debating your test. I might still push your test. Sorry, I'm in charge because we might just end up doing a Desmos activity tomorrow that helps you guys play with this. But I just wanted because I expected that question to be something we already knew. If your coefficient to x squared is positive, it's pointing up. Okay. I forget where I was going with this and why. Oh, so then we know an awful lot about this, right? So I'm going to erase this for a moment just to get some more space. We know everything needed to graph the parabola. Pretty much.
You and your dangly legs. Get out of my
Check it. X-intercept at 7 halves, which you guys already told me is really 3.5. X-intercept at 2/5, right? Less than 1. Y-intercept at 14.
That'd be a really steep line.
Oh.
Hold on, and then I'm way over teaching, which is fine because then we'll be able to go fast. How could I figure out my minimum? Or my maximum, which is
Minimum of what?
the lowest point on the graph or the highest point on the graph. My
Like,
min or my max.
Try creating like a geometric like slope, and then figuring out doing that
We're
like
trying way too hard.
basically just do that and then you reflect it.
Yeah, that's kind of on the right track. Steven?
I don't know if this is right, but do you plug in those numbers into like the x or something?
Plug in what numbers into the x?
Those things. X.
We already know what y equals when I plug those in. Y equals 0.
Oh, okay.
Because remember, this is y equals. And when I make my x is 0, y equals 14. Right? Because that's how we know that. Jacob?
Find like the midpoint of 2/5 and 7 halves, except I don't know how far to go down.
Your min and your max are always going to be the point dead in between your zeros.
Yeah, like what?
So
That's what I said.
Far down.
then, can we figure out what's between 2/5 and 7/2?
Maybe, yeah.
Yeah, I mean, especially if we make this like 0.4 and 3.5, just average them, right? 3.9 divided by 2 is
2.45. No, that's wrong. You're getting it right.
what's 40 divided by 2?
20.
20 or 2, right?
1.9.
But we're missing by a tenth. We'll cut that tenth in half. That's 1.95. What is that number? It's my what value?
Midpoint.
Well, what value of the midpoint? Well, not really midpoint. It's of the minimum. That's the x, right?
Ooh. So then you plug that in for x.
And that will tell you where your minimum is. And from there you got like everything.
Well,
And this is a reflection.
yeah.
Because parabolas are perfectly reflectable. So this point can also be reflected out to here.
Oh.
And I can make my parabola because now I have 5 points.
Doesn't it really look like it's reflected?
It's probably drawn wrong.
That is drawn horribly wrong.
So I am not an artist, but so guys, it's amazing how much we're able to do once we factor it. So that's what we're getting at today: is how do we factor these trinomials to make the rest of the process a whole lot easier. No, we've done one problem.
Can we do a half a problem and then do a
We have 10 minutes left. We can do a single problem of our notes.
Well, we did like one.
We drew a
Sometimes
square.
there are more important things. All right, so there's another way.
God, tier notes.
There's another way we can represent this, and I'm gonna try to go quickly here. So to figure out 2x squared and to make 6, we've got some like options, right? Because there's multiple ways that we can multiply up and get 2x squared. But man, I'm trying to. We have 10 minutes. Are you just now starting notes?
No. Mr. Hudson.
Yeah.
Mr. Hudson.
No, he has notes out right now.
This is my notes.
Wait.
So
yes.
the magic diamonds, and because we're still in the transition years of CPM, and they just say diamond problem or whatever, but if we set up our area model in a diamond problem model,
That's why we're doing these.
so we know the product, right? But so how would 2x squared and 6 work into this?
It was almost like
These don't seem
the
useless.
diagonals have
Thomas?
Sum is 7x, and the product is
Yes.
Yeah.
Because when you
I think the 2x.
So take a moment, don't talk. Think on your own. How do you think we can utilize the connection between the area model rectangle and our diamond magic whatever thing? I call them magic diamonds, and the 7th grade keeps getting mad at me because that's not what CPM calls it.
Wait, they're doing those?
Yeah, but at a really low level.
Exactly. Like, why are they mad? They didn't create
We have better math.
They have no right.
Well, because then I'm using words they're not using in their homework. But all right, so quietly, just think about that for a moment. I love those moments though. Where you can't help but like say it out loud because you're like, oh my gosh, it works. How do we get to the point of Well, actually, sorry, this is given to us. I keep kind of jumping around in my head. So if the 7x is given to us, we know that between the two of these, we got to add up to 7x.
3 and 4 would be logical, but that's probably not happening.
3 and 4 would be a logical breakdown for the 7.
But it's
CPM
CPM, so it's
actually
probably
works.
something with really complex.
You know what?
It is
3 and 4 works, I think.
Wait,
So,
three right there?
how-
4 right there.
Let's try this out then. So you think you got a method? What do I put in here? How does this relate?
Oh!
Sum is the
Oh, I
7x
totally
and
get
the
that now.
product is
Ooh.
the 6 multiplied by the 2x squared.
So the product is 12x squared?
Yep.
Yeah.
HSM2 is probably.
Because if all I know are those pieces,
3x and 4x.
Yeah.
then I can figure out that 3x and 4x have to be those beginnings of my binomials.
So you
Or
just
sorry,
like-
not the beginnings of my
multiply
bi-
those two.
the coefficients of, sorry, I said that wrong, the coefficients of my parts.
So how do you get 12x?
2x
Multiply
squared
6
times
and 2x squared.
Diagonal method. So if we look
I never learned the diagonal.
at,
That's
hold on,
either-
I'm probably going too fast, and this is the issue with how long we took at the beginning of class for
That's what
random
that
stuff.
was.
Yes.
Okay.
So if we go back here, anyone want to jump in and explain it, or do I?
I was wondering when they talked about the diagonal method in last night's
What's the
homework.
diagonal? I don't remember.
If you multiply.
If you
Cross
want to
multiply.
if you get the sum of the
Cross multiply.
No.
Cross multiply?
Yes.
Okay.
Product is multiple.
Who can explain it?
Hold on, I just need to know the difference between sum, addition.
Sums addition. The
Okay.
product is what is
If you
produced.
take
You're
if you
meant
take
to, and
6
you're
and
gonna
2x
let
and
some-
multiply them together, you get the product. No.
Yes.
Yes.
Yes, the product of this and that. So like this and that equals product of this and that.
Okay. How does that relate with like what
Wait.
Miguel's trying to do?
Eyes. Wait, no, never mind.
Miguel wants to
That's
stop
not-
here. You just take
No,
8x,
go ahead.
8 times 3x squared, and then you get the product of this and that.
You put the
So
product on
8,
top.
16,
You
20.
take
So I'd
the
have
10x, you put
24x
down on the
squared
bottom,
here.
and this goes. You fix it.
No.
Crap!
Uh-oh.
I did not want to move
Is
that.
that candy cane?
Well, my
Always
recording
has
is completely screwed up now. There
Here,
we go.
watching people, he messed it up, so leave
It's on him.
You don't say watching people, you say
Blame us.
viewers. What same thing?
Yeah,
Watching.
Oh,
you gotta
So wait,
remember-
I'm confused. So you guys said 24x squared here because 8 times 3x
No, wait.
Yes.
for the product.
Yeah,
And what
it would
goes
be-
here?
It would be
It'd
8x.
be the, what's it called, 10x.
10x, right?
It'd be
Because
10x.
that's what I need to add up and get.
So font, no, it would
I'm
be 5.
totally doing that instead of trying with the...
6 and 4. 6 and 4.
6 and 4 can make 24, right?
4 and 6, actually.
Dude,
It doesn't matter.
So then we know one of these is 6x, one of these is 4x, but based off this 3 and that 8,
it's flipped.
yeah,
Oh,
I'm
yeah.
thinking that the 4x would work better at the top left,
Wait, what?
and the
Why?
6x would work
They're the
better
same
than here.
thing, though.
I know you can do it either way, but so, and actually there's multiple right representations of the factored form. Oh, we're running out of time too fast. So, we don't really use that 24x squared except to help us get our values, help us get our answers and what breaks down to make sense for factoring out the area. Because if we look at this physically, like we don't have time today, but if we actually look at this with algebra tiles and physical situations, this is how these pieces relate to each other because we're talking about dimensions. Right? So we're physically talking about what would be the dimension in this space, like the area. What would be the dimension in this space, the area? Together, what are their areas? Well, 10x, right? So if we do that here, sorry, back to the one that we were looking at. What goes here?
2x.
Oh, sorry, we already solved this one, didn't we?
12x.
And 14, sorry, we already looked at that. Here we have 6x squared plus 17x plus 12.
72x
That's a
squared.
tough one.
32x squared plus 17. That's
Yeah.
32x squared. And the one we said.
One on the bottom is 6.
See, this is where reflex counts.
6 and... No. Only they have to do something.
6 and 11 doesn't work.
6 and 11 doesn't work. 6 and 12
cannot
doesn't
use
work.
5
6
and
and 12.
12.
6 and 12 doesn't make 17.
Yeah, that's what I said. You can't use it.
9 and 8.
5 and 12.
9 and 8?
Yeah, 9 and 8 would work.
9x plus 8x.
That would work.
What was that, Chris?
Super effective.
So now we think about our rectangle. 9x, 8x,
I just thought of a
6x
random Harry
squared,
Potter
and
joke.
12. And now we got the whole thing, and we can factor out our dimensions from there. No, if it's a joke, you're off topic.
But it's about math. I mean, it's about teaching.
So if this is still slightly weird for you, this further guidance section is a good refresher of like explicitly written out detailed process of how we process, like how we get through this. You can also, I believe is a math notes box that goes over this. My screen is all screwed up.
Yeah,
I
I get
forget if
that.
it's right here.
It's
Yeah,
not like tangent.
this method. So
Well, that
check out the
actually
math
is
notes
pretty
box also if you need,
This box with the 2.
because we break apart the dimensions and just call them like A, B, C, and D. Well, A and C are going to be x values, right? So AC is going to be something x squared, but BC and AD just have a single x for their area parts in there, and then BD is a constant. Yes, because we're out of time.
What do you call someone who's teaching at Hogwarts?
A
What?
professor.
The mentor.
What was that?
That was Christopher.
All right, get out of here. On that bombshell, that's class for today.
Get it? The mentor? You get it.
I think we get it. That's not the issue, is whether or not we get it.
We get it. It just wasn't.
It's like everyone goes silent. Wait,
I
did you guys
sense
not
that
get the
you do
joke?
not understand.
No, we did.
You have the
do.
word.
We did. It's like I'm not even laughing. Disappointing.
You did. It just wasn't funny.
It's very
I
disappointing.
understood.
Understand it.
Disappointing